Hi everyone, this is Alex from Team Terra, a community-based initiative looking to educate, act, and advocate for renewable energy and environmental sustainability. Today, we just had Dr. Kammen on our lecture series, giving us an expert's guide on the future of renewable energy. Dr. Kammen is a renowned climate and renewable energy researcher, practitioner, and advocate. He is the founding director of the Renewable and Appropriate Energy Laboratory at UC Berkeley and has appeared multiple times on the New York Times, 90 Minutes, Nova, and much more. We talked about carbon emissions, intergovernmental efforts to reduce the effects of climate change, and much, much more. Following is a recording of the live talk. Enjoy.
And what I'll try to do pretty quickly, so we have lots of time to discuss these things, is to give you a feeling about what's happening in the world of clean energy, and also what are some of the interesting challenges that we face ahead. And as Alex said, I run something called the Renewable and Appropriate Energy Laboratory. We call it RAIL. And if you want to look at any of the things that we do, you can go to the website. It's not academic papers. Well, there is those too, but it's got a lot of videos and some of the field work we've done in Western China, in East Africa, with Native American populations. And then if you want to follow some of what the lab does, the Twitter is not my own personal Twitter feed. It's mainly projects in the group. And then for people in China in particular, the WeChat is at the bottom. And again, we use my name for these, but they're really for the projects and efforts in the laboratory, mainly science and policy, but a good dose of commentary as well on what's happening in the energy world around us. So I want to start off with something kind of technical, because it really sets the stage for how critical clean energy is, and then some of the decisions we have to make. So this is the famous "what do we do about climate change" graph that was circulated very widely in 2010 up to 2014, highlighting the path that the world was on, the red line, the so-called business as usual path, to warm the planet by more than 4.5 degrees Celsius by the end of this century. And when the planet warms by 4.5 degrees on average, it actually means the poles will warm by almost 20 degrees. And that's just hugely transformative. And if you think that's something that's coming in the future, guess again, we've had heat waves in Siberia this past summer where it was 100 degrees Fahrenheit when it should have been no more than in the 60s. So we're already seeing massive climate change all around us. The fires in California that I'll come back to in a bit, the fires in Australia, the dying of the Great Barrier Reef. So this was the path we were on. And what countries did was they committed to a whole series of what are called national direct contributions. Essentially, each country said how much they were going to do in terms of switching to renewable energy, preserving forests, preserving mangrove swamps and wetlands. And I'll explain a little bit why it's such a nice, big, chunky red wedge here, or red triangle, in a second. But again, we called these the commitments because no one had done them yet. And sadly, here we are in 2020, and basically no one has still done them. So they're great promises, but they haven't been acted on. And down here in the gray are new innovations beyond what nations committed to, that we still need to do better science, better policy, get the cost of electric vehicles cheaper, get it easier to put solar on the roof of your home or business. So these are the needed innovations. And so just kind of be thinking about these pink commitments and then these gray, these needed innovations, because I'll come back to those. Well, turns out that the Paris conference went so well. It was the 21st such conference, and it was a huge success. People committed to all of these cuts, but right away afterwards, US Secretary of State John Kerry, who I was working for, former senator from Massachusetts, helped on the US side to negotiate what are called the Kigali Accords. They don't get a lot of attention. They're another 0.5 degree, mainly by making our commercial refrigeration and some of our industrial processes more efficient. There are things we haven't done yet. You can see they have a bigger and bigger effect as we go further in time. But when you add all that up, more or less the world committed to cutting greenhouse gas impacts in half. So the red and this little bit of gray, things we said we do. Down here, things we don't know how to do yet or can't do cost effectively. Now, at the time, we were negotiating to try to keep global warming less than 2 degrees Celsius. Since then, we've seen the fires around the world, and we've now moved our commitment down to 1.5 degrees. And that's great to say it, but unfortunately, we've already warmed the planet by 1.1 degrees. So essentially, we only have 0.4 of a degree of headroom left for our 1.5 degree target, and we critically need to get there. When you think about how critical it is, I really need to go to one of my favorite movies, The Martian. All the red are things that we know how to do with existing technology. And I hope you've seen this movie. It's really great. I'm not going to swear at you, but the line I'm going to quote from the movie, you'll know why it's my favorite in a second, right? Of course, our astronaut, Watley, has to keep himself alive. And so what he says he's going to do is to science the blank out of it. And we're going to need to develop new technology. We're going to need to find ways to deploy it. And if you think that this was a great line in the movie, I think it was the best line in the movie. One of the best science communicators in the country, Neil Tyson, said, "My favorite line in The Martian, uttered by Matt Damon, is I'm going to have to science the blank out of it." And that's what we're going to need to make technologies available. Science doesn't solve the game, but it gives us the tools to get there. And when we talk about this 2 degree pathway versus the new 1.5 degree, you can see right here in each of these categories why we've chosen 1.5 degrees as our new target. In each case, from heat waves like we've seen in Australia and California, to seeing the Arctic ice free, to seeing loss of species, you can tell in each case it's 2 or 3 or sometimes 10 times worse if we make 2 degrees our target, not 1.5 degrees. And so this is why the global science community has said we have to set this lower target. Very little warming we can left do. That means very little additional deforestation, very little fossil fuel use that we can use. These are really, really stringent targets, given that unfortunately, while this is a great goal, only 2 countries worldwide are on pace to meet those targets. And they're not the countries you might think of. They're definitely not the United States. They're not Germany. They're not Britain. They're actually 2 African countries. Morocco and the Gambia are the only 2 countries that are on pace to make good on those commitments. So we are way, way, way behind. And that's why we've got to science the blank out of it. And so when we think about places that have made a serious effort, here in California, we committed to going to 20% of our electricity coming from renewables, green technologies, solar power, wind power, geothermal, that's hot underground temperature, wave energy, tidal power. And our goal was 20% by 2010, and we missed that goal. But the prices have improved so much over this past decade. And places like California and now New York State and Washington and New Mexico have gotten more and more aggressive. So while California didn't hit our 2010 target until 2013, we met our 2020 target of 1/3 powered by renewables in 2016 in just a few additional years. At that time, our goal for 2030 was 50%, but we got more aggressive, and California is now committed to be 100% powered by clean energy by 2045. And at that time, we upped our 2030 target to 60%. Now in California, we don't count nuclear power as a renewable, and we don't count large hydro that blocks rivers. Other places in the world do, but California's target is both very high and very aggressive. Now, when you look at the United States, the real question is, who's ready to do this? We all know there's a big divide between the red states and the blue states, where California is now committed to 100% clean energy, and we've now been joined by Washington State, by New Mexico, by Colorado, by New York, by Maine, by a number of states that have set targets like ours, carbon neutral by mid-century. If we wanted to know what the costs are, here's a graph of what's the least cost technology in different parts of the country. And I'll give you the names to go with it. So where you see rust color, that's natural gas. Where you see a little bit of blue, that's where nuclear is the cheapest, although this is kind of a complex calculation. The group that did it, University of Texas at Austin, they didn't actually include all of the waste management, which many of us think is the biggest part of the story. So it's a bit tricky. But green is the middle of the country where that's the cheapest, in New York State. I'm from right up here in the middle of the state. And then this purple is where solar is the cheapest. There's some pockets around the east and the center part of the country, but it's mainly the Southwest and in where I live right here in California, in Oakland. Now, this is when there's no penalty or no price on pollution. But thankfully in California, we don't live in that world. Any company that wants to pollute has to pay not $0 per ton of carbon dioxide, CO2 we emit. You have to pay 20 bucks. So let's crank up the number here in that carbon cost from 0 to 20. Here we are where it's 20%. I'll go back and forth so you can see how the map changes without getting you sick, I hope there. And here you can see what's basically happened is solar has expanded greatly at the expense of natural gas. Economists think that even this so-called market price is far below the cost in terms of damaged ecosystems, damaged kids' lungs, damage to the economy. They think that the social cost of carbon or the full economic cost is actually more like $50 a ton. So let's plug that in. Now you see for a new project done tomorrow morning in the United States, wind is the cheapest in much of the Midwest and upstate New York and kind of Appalachia. Solar is the cheapest in most of the country. That little pocket of nuclear holds on, and natural gas is really confined to some very rainy areas in the Northwest. So that already says that if we were honest with the costs, we could get there by technologies we have today. Now, I mentioned that Paris Climate Accord. That was in 2015. I really think this handshake was the critical moment. President Obama, Premier Xi of China, they signed an agreement between just two countries in 2014, and China said they would stop increasing their emissions in 2030. United States said we would cut our emissions by 1/3 by 2025. Well, we know what's happened instead. President Obama left office, very sad to me. Mr. Trump came in, and Mr. Trump promptly left this Paris Climate Accord. So that's not so good news. China is still on pace to peak their emissions by 2030, but then they've got to cut them down from there. Now, that's one of the reasons why my laboratory works very closely in China. These are just some images of work I do with some of the universities, North China Through Power and Tsinghua. They're based in Beijing. Here's Chongqing University in the Southwest. Here are some of the meetings with Chinese negotiators, Chinese ministers of science technology, some of our students, where we try to partner and work back and forth between my laboratory group and groups in China. And we're in a good spot in California. I mentioned that we're going to go carbon negative in 2045. This is the slow reduction we've done so far. This is the path we need to be on, which is steady reduction over the coming decades. And California, by most measures, is going to get there. You saw in that graph, we're going to be 60% powered by renewables just in 2030, and then we're going to keep powering down this curve, installing more and more clean energy, more and more clean vehicles. And examples of that are just in mid-September, Governor Newsom signed a proclamation that says California will end the sale of new gas-powered vehicles entirely before 2035. We think it's going to be sooner than that, but that already sets a line, a very clear line, that we're going to move off of gas-powered vehicles onto electric vehicles powered by renewable energy. China set their own standard, I mentioned, is peaking by 2030 and then going down from there. And this is the more technical graph of China's path. Emissions have been rising, they plan to peak them, the slope of that line hits 0 in 2030, and then it comes down gradually. I love this goal. I just wish China was being a little more aggressive, because the problem is, you see, they're going to start ramping down coal plants and ramping up more and more renewables, but they're going to count on what we call negative emissions. And that means they're going to count on burying carbon dioxide underground by a chemical process to capture it, which is expensive today. We don't do it in large scale. And by hoping nature sucks up more and more carbon. Well, If you grow a lot of trees, that's great, but the Chinese economy is growing, and other parts of the world where we've talked about buying that or investing in governments to do so are going the wrong direction. Brazil at one point thought they would offer for sale carbon sequestration. They would grow more forests like in the Amazon that would suck carbon down. That would be great. But Brazil's President Bolsonaro is about in the same camp as Mr. Trump. And between 1975, you can see all this is forested. And in 2009, you can see it's all deforested. And so what we think is happening actually is that the Amazon, the so-called lungs of the planet, are being cut out, leaving all this bare soil. Sometimes they grow soybeans on it. Sometimes they just let it sit. And so actually places that we might have been investing in to go carbon negative are having a hard time. China is not going to be likely growing many new forests domestically. And if places like Brazil are not going to be able to offer that as a service, it gets harder and harder. So I would like China to accelerate the green, to bend this curve faster and count less and less on these brown, these going negative. Well, one of the things I got to do by being a scientist working on climate was to work with President Obama as the science ambassador, the so-called science envoy. Here I am with the US ambassador to Morocco, one of the countries on target. And here I am as part of the team I worked in at the State Department. I do notice there's a little gender problem here, but Secretary of State John Kerry was my boss. And he was just announced by President-elect Biden to be the climate czar for getting the US back in shape. And actually the Biden climate plan is just wonderful. It says they want to go faster than California. They want to go to carbon neutral by 2035, 10 years faster than California. And here's the real kicker. President-elect Biden has said they want to devote 40% of all federal money they spend on clean energy to poor communities, minority communities, areas that have bad air quality that have not been invested in. That's to me really exciting. And that's out of a $2 trillion federal investment. And they think that will generate up to $5 trillion when you count the $3 trillion of the private sector. President-elect Biden has also said he is going to be a champion of social and racial justice, Black Lives Matter. So his vice president, my state senator, former senator, Kamala Harris, has said that she's going to push on this, and she's already authored a bill with Ocasio-Cortez to make climate justice, a racial justice, part of the team. Of course, also President-elect Biden said he's going to re-enter that Paris Climate Accord in day one. And so all of these actions are really exciting. Before the US election, policies worldwide, the commitment of China, a recent commitment by Japan to go carbon neutral in 2050, and by South Korea and by Denmark, we were on pace, if everyone did what they said, to only, in quotes, warm the planet by 3 degrees Celsius, 2.9. But now with the US on board, we're now talking about an optimistic pathway that could get us down to 2.1. Now that's still not at 1.5, but in a few months, we have a pathway now that takes us down to thinking about getting to just 2.1 degrees by investing in new solar projects, by investing in new wind technology, by investing in energy storage. All of these technologies are part of a pathway that gets us this kind of optimistic worldview where instead of being in this blue line, we could be down here. And of course, once we find ways to do that, we can really think about making that 1.5 degree pathway a possibility. So let me just show you one example of kind of thinking about the system that we could scale up. So this is an island in the South Pacific in French Polynesia, where I was asked to help design a 100% clean energy system. This is a former volcano in the middle of the Pacific Ocean. So when that happens, the volcano rises, the peak falls in. So you get these little remaining islands called motus around this core. It's deep and it's cold in the ocean outside. And so this is a snapshot, kind of a drawing of this one little atoll, this motu here. You can see the airstrip going through the middle of it. And we were asked to work with the government to design a clean energy mixture for the island. So this is what they now have. They have bungalows for visitors. It's a great place to go. You can see the beautiful water. There's the airstrip. There's a research station here. We were asked to design a 100% clean energy system. First thing we did was design and then install a large solar array next to the runway. Here I am landing with that big solar array along the side. And for all these buildings, the next thing we did was first, again, do the solar, but then install something called a biofuel refinery. So we harvest coconuts, we make biofuel whenever they need a liquid fuel. And if you grow as many coconuts as you consume in liquid form, photosynthesis means you're in balance. But it turns out solar's gotten so cheap, we decided not to do any of that. We have it as a backup in case there's hurricanes, but we don't use it. But instead, the first big project after the solar was something called SWAC, salt water air conditioning. All is pumping up that deep cold water from outside the reef, from out here in the dark blue, where the pipe goes down about a mile, actually goes down about a kilometer, I should say, goes down 900 meters, 9/10 of a kilometer. We pump up the cold water and use it to air condition all the units, the science buildings, etc. Next thing we did was install a big liquid battery. It's called a flow battery. It's much better than the batteries in your cell phones and laptops, because unlike your cell phone that only has a couple thousand cycles, this has 1,000,000 cycles before it starts to degrade. So that's, if you will, that's the energy bank for the island. And the next thing we're installing is actually a tank of fresh water anchored to the ocean floor. It bobs back and forth in the current, it generates power, but it also generates pressure that we use to make fresh water. And I'm showing this island because this already is 100% clean energy. And it's the kind of thing we need to make this goal work, where we need to learn and learn, install more and more new technology, better policies, invest in social justice for the poorest communities, and really make this package work so that we can definitively make good on those promises and not stick up here in this blue band, get on this lower path, preserve the world's rainforests, preserve the tropical reefs, preserve forests. And once we make this happen, keep learning, science the blank out of it to get down below 1.5 degrees. So let me open it up for questions and dialogue for our last 10 minutes, and want to thank you and hope that kind of gave you a feeling for what are our opportunities as we really move into a cleaner climate world. So Alex will run the show, but you can ask them verbally or type questions in, and let's use our last 10 minutes to talk about it.
Okay, so I myself have a couple of questions. Uh, should developed countries take the majority of the burden to reduce emissions? Because as we know, there are many developing countries in Middle East and Africa, and they might take the more traditional route of coal power plants instead of the alternative routes. And how do we encourage them to take the more renewable route?
So a lot of people debate this question because the rich countries, Japan, United States, Europe, Australia, developed first and used fossil fuels. Shouldn't poorer countries take that route? Well, that's why I showed you the plot across the United States. It might have been true that 3 decades ago or 2 decades ago, dirty energy was cheaper than clean energy, but it's not true anymore. You saw across the United States, clean energy is the cheapest, and it's not just here. This year, last year, and the year before, solar and wind power were the cheapest technologies anywhere in the world. And we see this in a whole bunch of different ways. As an example of that, here is a story of something that's happening in East Africa. And in East Africa, in Kenya, one of the challenges is that they've had a coal plant proposed to be built there. And that coal plant is going to be built right next to one of the great coral reefs in East Africa near a town called Lamu. The local residents here are protesting that coal plant. And the two funders of that plant were going to be the US company General Electric and the Chinese Industrial Commercial Bank. After this community group did protests, my laboratory wrote analyses finding that solar and wind and actually geothermal were cheaper. In the last few weeks, first at the end of September, General Electric abandoned the plant, and more recently, middle of November, the Chinese have abandoned the plant. Now, we're hoping they don't abandon Kenya. We're hoping they build clean energy. but it's just not the case anymore that these dirty plants are a better deal than the clean ones. And that's why I think what'll happen is if the developed countries keep their promise, which they haven't so far in terms of decarbonizing their own economy, what we'll see is that everywhere clean energy will be the cheaper option.
Okay, that's a great answer. We have another question, which is, since most of the audience here are high school students, maybe thinking about where they should go later in their career, for students who are interested in new energy jobs, what would be your suggestions?
Well, it's already a pretty interesting situation. 10 years ago, the California solar industry was just starting to grow. It was ramping up. But what has happened since is that solar has grown so rapidly. Here, for example, is a housing development in California. This is one that opened just 2 months ago. And starting January 1st of this current year, every new home in California, both single family homes like this yellow one you can see over here, and these larger multi-family homes, here you can see in the middle like this blue one, any new home you build in California now must generate as much energy from renewables as it consumes during the year. And so California has now flipped. There are now more people in the solar industry in California, about 80,000 solar jobs, than there are working at all of the traditional utilities. So from my view, it's already switched over. Here, for example, is a battery system. It's that flow battery I mentioned, powered by solar. And there are more jobs in this clean energy space than there are in the dirty energy world. And so I actually think that we will be in a situation where we are seeing more jobs in this area than in fossil fuels. So for me, training in clean energy at Berkeley, we have an energy engineering major. I have a friend who teaches at MIT, a friend at University of Illinois. We see more jobs in all these areas than in fossil fuel today.
Yeah, it's a great industry to go into, and one definitely has a lot of promise. So, we have time for about one more question. So, let's talk about the elephant in the room. COVID-19, and how has COVID-19 affected our race towards the goals set by by the Paris Climate Accords?
Well, COVID hasn't actually affected things that much. You guys all may remember that at the peak, or what we had hoped back then was going to be the peak around the world, we saw clearer skies. There were seeing wild animals in cities. There were reports of mountain lions and coyotes in downtown San Francisco. Rare wild cats were seen in New Delhi. Well, that was interesting. Emissions fell briefly. But what we've seen around the world is that emissions have risen back up. China is now back up to their pre-COVID pollution levels. We measure it with satellites. We see the amount of carbon dioxide and methane in the air. It's the same as it was prior to COVID. And you all see the United States is just mismanaging this to death. And so while US economy is tanked, our emissions have crept back up. So COVID hasn't had a whole lot of effect so far. It doesn't mean it won't in the future. A number of countries, already South Korea and Austria and New Zealand, they've all said that their stimulus packages are going to be focused on clean energy because that's where the jobs are. And I'm hoping that President-elect Biden will do the same. I'm actually pretty confident that the US will under President Biden as well. And that's why that graph I showed you, where we're now at a place where the world, if we make good on our promises, is heading towards this path of only 2.1 degrees. I say only because that's still going to be horrific, but it's a lot better. And in fact, just to answer the question that popped up about universities, I of course think that Berkeley is the best university for clean energy, but Stanford and MIT and Carnegie Mellon and Cornell and Boston University are all great places for clean energy where they have really interesting specific programs. And really most universities now are ramping up. Columbia in the Columbia Earth Institute, University of Washington in their Center for Clean Chemistry. It's really something that you can find in all kinds of universities and colleges today.
Okay, that's for students looking to go to college for that type of thing. It's very useful. We have a question from Lyle, and their question is the wave energy and desalination system used in the islands. Do you think those are commercially viable for use on a much larger scale?
So I don't think I mean, they are becoming cost effective. I don't think they're going to be the large scale option. And the reason why is that those systems tend to work best near shore, where you get big tides, shallower water, all the energy in the wave comes in. That's why we have waves. They get translated to energy that we can harvest. And so there are lots of communities that can be really well served that way. But I'm going to share my screen again. If it'll let me. It's not letting me right now. I think you might have changed something in the setting. Let me try it again. Yeah, it doesn't want to let me share it. I think you might have turned off screen sharing. But I think there's another form. There we go. There's another form of ocean energy, which is really exciting. And I just happen to have a slide stashed away somewhere here for it. And that is not these tidal systems, but actually offshore large scale wind. And one of the really exciting features of very large offshore turbines is that they don't really bother anybody. They're kind of out of sight, out of mind, although the United States has found ways to object to them near the homes of rich people. I won't mention where, Cape Cod. But off the coast of China and across the coast of Europe, they're already doing this. And if you look at this map of wave energy power off the California coast, we actually think that there's so much wave energy, and so much offshore wind energy available, notably in these red areas, so northern part of the state. We think that California, which is the largest energy consumer in the country, could actually get a quarter of its energy from offshore wind with these big 300-foot tall turbines by the end of this decade. And that's like finding a quarter of your new energy. These are already at commercially viable cost. We see this happening off the Delaware coast. New York State wants to install almost exactly the same amount as California. China's looking at it. It's already going on in England, Scotland. So I actually think it's these large offshore wind turbines that are likely to be the bigger part of that future. When the demand for power goes down, they'll probably use these turbines to make hydrogen. And either by pipeline or by boats pulling up, will use that hydrogen as a way to store energy and then use it for industrial uses. So I see the next big thing happening is really the ramp up of offshore wave energy to complement onshore wind, onshore solar, and other technologies. So it's definitely a great question.
Okay, so let's end off with this question about what can high schoolers do now to prepare for green energy jobs and if they're going to college looking to study that type of thing.
So actually, because there's so many features of this field, it really is major in what you want and you will find a way in. And that's because there are so many jobs in clean energy, like I mentioned before, many more jobs than the fossil industry. But it's not just about technology. In this talk, I've sort of emphasized the hardware aspects, but we need to do much more to bring clean energy to the poorest communities, something we call environmental and social and racial justice. We need to work on the laws that permit clean energy. Right now, there are many states, for example, that don't permit large, tall wind turbines, but interestingly do permit large, tall gas rigs. And that's just because that's the history of what they're used to. So we need environmental lawyers, we need environmental sociologists, we need people who think about and design those kind of buildings I showed would have solar built into them. So I would say major in what you want, but make sure you take some courses on energy, on climate change, so that you're really learning about what are these challenges. But what you major in won't matter. It's just how you apply it to this evolving industry.
Okay, thank you for the insightful answers. Well, everyone, I hope you learned a lot from this talk with Dr. Kammen, and we'll have many more with many more talks coming up, and we'll let you know about when they're coming. And thank you all for attending.
Thank you all. Really appreciate. Hope it was useful and enjoy. And like I said, just jump in on this. There's lots of cool stuff to do. And if you look at that Twitter I put out there, you'll see we try to post something each day about what we're doing in the lab. Take care.
Yeah. Oh, and also if any of you guys missed some of this presentation, it will all be uploaded to our website at teamterra.org. So you guys can see that later. Thank you.
Take care. Thanks so much.
Thank you.